So it's pretty wild to just be in Palo Alto with a bunch of cubes, and then a humanoid robot just walks past. We've made a massive amount of progress with Optimus in a short period of time, from someone pretending to be a robot dancing in a suit, to a pretty hodgepodgey robot, to a robot that is actually doing useful tasks in the factory today. So we have 2 Optimus robots in our Fremont factory that are doing basically this task, which is taking cells off the end of the line and placing them in a shipping container. And yeah, we actually have quite a few of these cruising around our offices in Palo Alto. So there's, and I think we've got kind of like one major hardware revision, which should be done by end of this year or early next, and then we'll move into a limited production next year of Optimus. Limited production for use in our factories, where we'll test out the product, kind of, as I say, sort of eat our own dog food or whatever the electronic equivalent of that is. But I think like next year, my prediction is next year we'll have over 1,000, maybe a few thousand Optimus robots working at Tesla. And things are going to scale up very rapidly from there. So we'll iron out the bugs. Like the degree of autonomy will be radically better. You'll just literally be able to talk to it and say, please do this task, or I'm going to show you something. Now do the thing that I'm showing you. Get to the point where it can watch a video of something like a person and then learn just by looking at that video and do that task. So, yeah. So really it's going to be quite something. And I'm confident of the prediction that there will be more, like the ratio of humanoid robots to humans will be greater than 1 to 1. So that there'll be, more than 10 billion humanoid robots in the world, probably 20 or more. And Tesla's going to be by far the leader in that. You're seeing a lot of robot startups, but I think it's actually very challenging to do Optimus as a robot startup, because what we found, to make Optimus work, we've had to design from first principles, from scratch, every part of the robot. So the motor, the gearbox, the sensors, the power electronics, the communication system, everything had to be done from scratch. We found that there's basically nothing. There's no supply chain. So even though there are many electric motors made in the world, there's no supply chain for the types of motors and sensors and gearboxes that are needed for a humanoid robot. What you're seeing here is our current generation hand and arm, but our next which has 11 degrees of freedom. Our next generation has 22 degrees of freedom. It will be able to play the piano. So it's really like, wow. Now, of course, like I said, we need to make sure we don't have the Terminator scenario. That's very important. Safety of the humanoid robot will be very important. But because it requires so much ground-up designing every motor, gearbox, sensor, power electronics from scratch, it's very hard for a startup to, if not impossible, for a startup to replicate that. But at Tesla, we have the world's best electrical engineering. I think we've got the world's best mechanical engineering for gearboxes and for electric motors, power electronics. We have the resources to do that. It applies quite well. And then you also have to have the brain. You need a power-efficient inference computer, which we've got for the car, and we'll be using an Optimus. You need AI. You need to be the best in real-world AI, and Tesla's the best in real-world AI. So you need all of these. You need a very strong hand of cards in order to make a compelling robot. And then you also need to be very good at scale manufacturing. So in order to have the robot not cost like hundreds of thousands of dollars, in order to make it cost like $10,000 or $20,000, you actually need to design for manufacturing and be very good at manufacturing. And in my experience, prototypes are easy compared to volume manufacturing. Prototypes are easy, production is hard, relatively speaking. So Tesla has the production capability, it has the engineering capability, and it has the AI hardware and software capability. And even the most optimistic estimates that I've seen for Optimus, the optimist, I think undercount the magnitude of what this robot will be able to do. As I said at the beginning of the presentation, I agree with the ARK Invest analysis that autonomous transport is called sort of a $5 to $7 trillion market cap situation. Optimus, I think, is a 25, literally $25 trillion market cap situation. So. Now, I don't want to trivialize what's necessary to get there. I mean, it's an immense amount of work that is required to get there, like super difficult. But we are moving very fast down that road, and we're going to make it happen. So, thank you.